Dr. Atkinson has his trusty bow and arrow. Okay, so we're talking about combustion. If you're combusting something with carbon and there's enough oxygen, you'll have complete combustion, producing CO2. But if there is insufficient oxygen, when you burn these chemicals with carbon, you'll produce carbon monoxide or carbon, also known as smoke. If there's hydrogen present, that will produce water too. Okay, so these questions are normally multiple choice. Hydrocarbon with molar mass 70 grams per mole, fully combusted in air. Okay, so the hydrocarbon is going to be CXHY, hydrogen and carbon, and combusted in air, it's going to be O2. I'm going to make some carbon dioxide, and I'm going to make some water. Now we have to balance this. It's the same way each time. I'm going to have X carbon dioxides because I'm locked in by that X there. And for water, I'm going to have Y divided by 2 waters because I'm locked in by the Y here. If you don't understand that, don't worry about it. Just memorize it. What about this here? You don't need it. You're just slowing down yourself in the exam. Right, I'm going to draw out the boxes method. So filling in what we've got, 660 grams of carbon dioxide and 270 grams of water. I'm going to need to work out the moles pretty much every time in chemistry. That's what you're doing. So for the molar mass of carbon dioxide, well, looking at the periodic table in my brain, it's 12 plus 16 plus 16. So that's going to give me 44. And water is going to give me 18 because that's 1 plus 1 for the hydrogen, 16 for the oxygen. Now moles is mass over molar mass, which means that 660 divided by 44 is going to be the moles there, which is 15. That's nice. And 270 divided by 18 is going to be the moles there. 15. Nice round numbers. Okay, from there I know that the ratio between X to Y over 2, it's 15 and 15. So I know that X is 15 and I know that Y over 2 is 15, giving me Y is 30. Now looking for the empirical formula, the simplest ratio of atoms in the compound, I've kind of got C15H30, but I want the empirical formula, the simplest ratio. So you can divide by the smallest, in this case 15, to give me C1H2, empirical formula. Now to get the molecular formula, the actual number of atoms in the compound, well, I mean, the real compound, that's how I think about it. It could be C1H2, and if that was true, it would have a molar mass of 14 grams per mole. Or it could be, I don't know, C10H20 for 140 grams per mole. There's infinite possibilities. So how do I know which is the real formula, the molecular formula? Well, I do know that the real thing has a molar mass of 70 grams per mole. So the simple calculation, if I take the molar mass of the molecular formula and I divide it by the molar mass of the empirical formula, that's going to give me 70 divided by 14. That's going to give me 5. Aha! So I know that the empirical formula needs to be multiplied by 5 to get the molecular formula. So the molecular formula is going to be C5H10. Nice. You've got to be able to do that in about a minute and a half without a calculator. Good luck with that.